Welcome, everyone. My name is Toby. I'm from PhraseApp from Hamburg. We're a software platform where you can translate or localize your software, software as a service. So, in case you have any questions regarding that, there will be nothing regarding that covered in the later bits of the talk. But if you have any questions regarding that, feel free to ask me. I brought some stickers as well, so you can grab a sticker later. And yeah, so today I want to do a live coding session regarding Go on Kubernetes, and the topics which will be covered will be the initial cluster setup of Kubernetes. That will be a single node cluster, but I will be using kubeadm, which is a tool from Kubernetes with which you can use and bootstrap a cluster. And most of the or all of it, what I will be doing will be done in a tmux session. So you will see a little bit of like tmux magic. I will be using VI, so also like how to work with Go in VI will be a topic, and obviously Go. And what I will try to do is create a simple like microservice kind of thing with a REST API in Go. You will probably not learn too much, but it will be more like a talk to get an inspiration or to see how working on a Go microservice in a setup like this works, and maybe you get also some inspiration that you should look into using tmux more or VI or yeah, whatever. But let's get the thing started. So first of all, we need a cluster setup, and yeah, and by the way, I think that I didn't have it. I'll show the repository, all the bits I will be using. It's already on GitHub and in the repository, so you can check out all the configuration files I will be using. And I will also push like what I ended up creating to that GitHub repository. I'll show the link at the end. So first of all, I'm running here in a remote session on just a bare metal server. So this is not no like hosted Kubernetes or whatever. It's just a bare metal server. And first of all, I want to create the cluster, so I create a little setup script. It's 40 lines of code. So this is a CentOS installation. So first of all, I need to add the Kubernetes package repository here. Then I do a little bit of Docker configuration. So I changed the storage driver to overlay 2 so that it's a little bit faster. And then the default configuration was that Docker would log to the journal. I don't want that because it doesn't play well with Kubernetes. So that's these bits. That's basically only a complicated way of writing configuration files here, that sudo t thing, because I don't want to run that whole script as root. And then I just install Docker, kubelet, which is one bit of Kubernetes, kubeadm, and kubectl, which is the like the CLI tool for Kubernetes, just from the repositories. Enable kubelet and Docker, that's systemd, enabling them so that they are running, and then this is the script to initialize the cluster, basically. So I can already start that. Let me see how am I doing this. So this is like already like this tmux session I already told you about. So I'm just starting that. It probably takes like 1 to 2 minutes. So you see, for example, now it's installing all the packages, etc. And while this is running, we can look into the setup, like the later bits. So that's this. So that's the init command. I think this is already running here. And then I create a configuration directory in my home where I copy the certificate which kubeadm is generating for me, puts in. And then there is like 2 extra calls. This call basically tells the cluster, oh, this is not visible. That's not good. Yeah. This call in line 40 tells the cluster that it can also, like, we are bootstrapping the master here, And this tells the cluster that it can also process normal workloads, basically. And then this is the call to create the network layer. So Kubernetes runs a virtual network, and I use Flannel here. And so this makes the pods able to communicate with each other. So that already like finished, and what I can now do is see what I got. So let's look at kubectl get pods. All namespaces. Yeah, it is still initializing, so even though the command finished, this is still like spinning up pods, so you will see more pods available here soon. So let's watch that a little bit. So now you see, for example, the etcd is starting in the pending state, the API server is starting. Feel free to ask me about any details regarding Kubernetes later, maybe. So yeah, we can just wait for that to be available. So this is running on the right side. And if something's not visible on the screen, please interrupt me any moment, because I have a different setup here, so it's a bit complicated. Okay, so let's see. I think we now have everything running. Did I miss something? No. So this is my cluster, so I can now play with the cluster. So this is what I would even consider a production-ready cluster. Not a cluster, many nodes, but I can use that command, which you maybe saw before here, this one. And I could use run that on any node and then just join the cluster. Okay, cool. So so I also want to have some way for monitoring and for logging and log aggregation, etc. in my cluster, and I also need some load balancing, and this is what I will be doing next. So maybe first of all start with the load balancing pieces. So the idea is to deploy that to the internet, and for that I need a pod which is running in the cluster, and I will be starting with just a simple nginx. So I say kubectl run image is nginx, and I name that CT 2017. So what Kubernetes now did for me is create a deployment in the cluster, and when I look at the pods running, you see that there is one pod running, and that means that there is a container in that pod running, and there is an nginx somewhere in that container, but it's really hard to access that container right now because that's the networking bit, because I don't have access to that network. So the next thing I'm going to do is expose that container as a service, and for that I say kubectl expose deployments nginx CT 2017. I tell it I'm interested in port 80, and I say type is node port. So this created a service for me, which I can also query here. Get service. And first of all, this service can be used in the cluster to communicate to the nginx, but I can also use it as a specified node port, that I can also access it on this host where I'm on, and that's via port like the 30,000-ish thing. So this one here. So this is like my way of copy-pasting tmux. So this is like VI bindings, and I don't need the mouse at all. So I can just query that on localhost. And this is like the default nginx index page, basically. So I have it accessible on the host, but now I need to want to expose it to the outside world. And for that, I will be using a concept called an ingress. And an ingress is a load balancer running in the cluster. For that, I have like a couple of recipes here. And let's look at the configuration. So to communicate with the cluster, whoa. It's okay. Maybe it's a little bit, maybe I can do it a little bit smaller. Let's see. Where is my mouse? Is that too small? Probably not. Okay, cool. So with Kubernetes has an API, and you can describe what you want to run in the cluster, and the default way I would say is to use a YAML descriptions of, and then throw these YAML descriptions on the cluster or on your API, and then Kubernetes figures out what to do with them. And so this is like the ingress configuration. This is, I didn't write that myself. This is just copied from one of the repositories I put in the README on GitHub. So you basically only copy this file and then you run it, and then you have a load balancer running. First of all, it needs a namespace and then a default backend, because ingress is a routing concept, so you can actually use the Kubernetes API to route requests to specific services in your cluster and then expose that externally. And then, so there's a default backend, so this is the deployment of the default backend, this is the service account. So this is where things are a little bit more complicated now since Kubernetes 1.6. You have like these fine-grained access control rules and RBAC, and so quite a lot of these services which use information from the cluster need extra like roles, something like IAM policy, similar to that on AWS, I would say. So this is like this, but as I said, copied over from some GitHub repository. And then finally, there is a deployment which says, please run Nginx and please monitor the cluster and then do some routing for me. So when I have that file, I can just say kubectl apply -f ingress. Then all the bits in the file are now like created. And when I watch the pods now, maybe I keep that just running here. You see that there is now also the ingress, Nginx ingress controller running in the cluster. And another thing I need now is I also want to terminate TLS. So I don't want my super cool service to be non-secure. And for that, there is another thing called kubelego. And Lego is what is it? Is it a library? I think Lego is the Go library to get TLS certificates from Let's Encrypt, and there is a recipe to run that in your cluster as well. So that's the kubelego bit here. It's similar. The role-based thing is almost the same as you saw in the ingress one, and this is just also like taken from the internet and running kubelego in my cluster. So I can apply that. So I'm quite lazy, so I have an alias for kubectl, which is K. So every time I type K something, that's just an alias for kubectl. Then I apply that kubelego thing. So you see instantly that there is like a new pod being created. So this is like the pods running on the cluster here. It has a health check, so it takes some time for it to be available. So now it's available. And yeah, and now I want to actually deploy that Nginx running in the cluster to the outside world. And for that, I have a deployment. And this is like a configuration of the ingress. And this is like just only this bit is the configuration that I say, this is the important thing. I want to expose that CT 2017 service, which I just created, port 80 on path to this host name here. I already created a DNS record for that, so that's already pointing it because I didn't want to wait for DNS propagation, and I also configured that I want to have a TLS certificate for that domain. And we can maybe watch here what's going on in the log. So with the Kubernetes API, I can also say, please log what's ever going on in that pod. This is running in a different namespace, so I need to prefix the namespace. And see, nothing's going on because there is no work to do. But when I apply this default ingress now, you see that there is something going on. It figured out that it needs to get a new certificate from Let's Encrypt, and I hope I don't run into any rate limits because I tested this quite often, and I did run into rate limits, so I had to change the domain a little bit. But it looks like that everything worked fine, and now I can hopefully query that thing here. Takes some time, and I even get like a 301 redirect to the secure version of that. So whenever I access that, done. So this is now public. This everyone could access that right now, and so this is like the basic setup I need, and now I can actually start like writing my program. So let's see how I'm in the time. 15 minutes. Quite good. So well, yeah, that kube Lego also takes care of renewing the certificates. You don't have to do with anything, so that's that. Yeah, I also told you I want to do some logging and monitoring. Maybe do a quick thing here. So Prometheus is a service which is monitoring all the services, containers, whatever in my cluster. So also taken from the internet. It has a bit of a quite verbose configuration. Because I think Prometheus was built before Kubernetes was that popular, so you have to configure quite a few things manually. But and then with that configuration, Prometheus would automatically be able to monitor what's going on in your cluster and figuring out that you start a new node and export like the container metrics, etc. And so yeah, deployment, etc. I will not go into any details. The rule thing as well. So I can just apply that. So and the next thing is logging. So all the containers log to the local file system. So in the cluster I want to have something which collects these. And for that I use fluentd, which is just a daemon running on all the nodes in the cluster as a daemon set with a specific configuration that it just like uses the logs and then sends them to a Elasticsearch Kibana cluster, which I have here. So this is a manual created but not complicated. It also has an ingress here. So maybe first start the Kibana and then the fluentd. And now I should have logging and monitoring in the cluster. So 1 minute. OK. We can maybe look into that later then. So did I miss anything? No. So that's basically the setup. And now I can do what I enjoy most, and that's coding and Go. So let's go here. So let's get started. I do have some, for example, the Kibana would be exposed publicly on the internet, so I want to have some authentication in front of that, and also the Prometheus. Not sure if I still have the, yeah, we could maybe look into that, but this is getting really complicated for me. So let's see, maybe I hit it. No, not this one. No, this is our production one. Let's see, maybe. Yes. So there is basic auth in front of it. You could try it. My basic auth was cached. So this is the running Prometheus in the cluster. That domain was also like the certificate was automatically fetched because I created this ingress rule. And here I could say RSS is my favorite one, for example. And then hopefully. No, I think I do. So this is like all the containers in the cluster and the resident set size of the memory, basically. And if I could click that graph thing, then that would maybe. Nope. Yes. Shit. No. Yes. So these are the graphs here. So it's only running for like 2 minutes now, I would say. To see one is already spiking. That's probably the Elasticsearch one because of the log indexing. But yeah, somehow worked. Fine. Let's get back to coding. So yeah, I need a basic auth proxy. I also like wrote a little basic auth proxy here in Go. You can look into code later. But I will be working on my new service, and that the service should be something where I can post messages via API. So let's do this. I'm just deleting. I do have some boilerplate already here, so I don't have to type all that. Yeah, let's see. I will probably be not leaving my VI soon. So this is my VI session, and then I'm using a plugin. Oh shit. Yeah. There's a tmux split pane here, and so I now can run commands quite quickly here on the right side without losing focus of on my editor. That's vmux, I think it's called. So you can also like look into my vimrc and tmuxconf. I can add the links to these files that are public as well later maybe. Okay, let's get started. First of all, let's create a Hello World application. And in Go, the only thing you need to do is create a something like this. Hello code. Talks 2017. So I'm using Vim Go, which is a really, really nice bundle of plugins, which, for example, automatically added this import statement here. So I don't have to write import log. It figures out that I want to use the log package that's from standardlib, and then automatically adds that. The problem with Go is, or it's not a problem, is that when you have an import and you don't use the import, the program doesn't compile. And so you clean up your imports on a regular basis. But with that plugin, I cannot reproduce that because whenever I delete that line, this thing goes away as well. So I cannot use that. So what I do have here is something like autocomplete. So I can go through, and that's like as a type safe, and I see, for example, which functions I can call on this log package, like that's actual global functions, and I can also go to into the definition. And now I'm working on the standard lib of Go, and so you can dive through the whole standard lib and figure out how is that log printf implemented, for example. But I just want to run it. So it's not running. Why is that? Because I'm not in the correct directory here. So now it's running. So this is my hello world. And because I maybe want to change some bits of what I'm running here in that session, I tend to create what I call a whip file. So that's my current work in progress. So I say go run main Go. And this is an indirection layer. And every time I add something here, I don't need to change what I configured. I can just use a text file. So clearing the screen and running that. So that's the first version of it, but I want to have it as an HTTP service. Okay. So how do I write a server? That's one line of code in Go. That's just HTTP listen and serve. Yep, typo. Yes. Okay, so now net HTTP is added, and I need to provide a port. I'm just picking 3000 and something here. So this is a server. It's a bit complicated to test. There's probably nothing going on, but I'm running this thing here. First of all, compiling the thing, which doesn't work. So now I can have a statically linked binary with the server embedded, and this is a production grade server. So I can just use that binary then and throw it on the server or in some Docker container, and I don't need any Nginx, Apache, etc. in front of that. And I can just run that, but you don't see anything here. But I could curl like localhost. But I am getting a 404 because that server doesn't know what to do basically. So what I can do now is, and I'm running that server here. I can create a handler index, and in that handler, I say hello code talks 2017, and I can now use that handler here. But now I would need to rebuild the server. So I would need to recompile it and restart it here. So maybe let's add a log statement. Starting up. So I know that's actually running. But I would need to say go install dot and then ct 2017. And then I could go here. And now I get the hello world here at the server level. But the problem is that it's like too complicated for me, so I built a little tool which is just reloading the binary whenever the binary changes. So running this, so I can leave that running, and now I just need to update sleep 1. So what I'm now doing is I'm compiling the binary with go install, then wait for 1 second. It doesn't take 1 second, but I want to figure out when it's actually available. 1 second is enough, and then I can curl it. And so this is my whip file now, and then I just run it like this. So you see the servers are automatically restarting. And to prove that, I just add more exclamation marks. Okay, so this is working, maybe even a little bit nicer. So maybe it's time to actually deploy that thing to my cluster. Yeah, and for that, I created a little Docker file. That Docker file is just built on the Alpine Go image, basically, and then I add install CA certificates. Maybe I might need them for external communication. I don't deal with TLS in my binary. And then I just copy over the source code in a specific file in the Docker image. I already integrate an option so I can provide the revision, which I'm building here. And then I just build it somewhere, and I start it when I start the image. So that's the one thing, just a simple Docker file. I could just build, probably, hopefully. Ah, you don't see that. So nothing fancy. And now I need a deploy tool. And for that, I created this shell script, which is not that complicated, I would say. First of all, normally I would only deploy Git pushes or build chars revisions. But for this demo, I'm just creating the MD5 sum of all the files in my current directory, and whenever that changes, I have a new revision, basically. And then I have an image tag here, and then I build that, and I provide a build arc, the revision, and the image tag. And these are actually the two commands here I need to use to deploy that thing. I already have that CT 2017 deployment, and I just say tell the API set image, and then please use the new image. And this is the bit where the kubectl command line tool just waits for the rollout to happen. But for that, I need to change a little bit in the cluster. So first of all, I only have one pod running. And for that, the deployment, normally the deployment works in a rolling way. So it adds new pods and then removes old pods. But if I only have one, it just terminates the pod and creates a new pod. And I don't like that. So let's scale the cluster up to maybe, or the deployment up to 3. That's not. Let me see. Can you see that? Oh, it's also not so good. So like this. Kubectl scale deployments, CT 2017 replicas 3. Oops. Typo. See, now I have 2, 3 running in the cluster. Maybe I can go back to my watching here. I will not be using the local server anymore because I now will be using the cluster to actually deploy my changes. So I can go to watching here and maybe only look into the pods currently running and maybe only the name. So you see here what's currently running in the cluster. This is still my whip session here. And yeah. And then I need to run the deploy script, but I do have to change one thing. Deployments, CT 2017. And that's my image pull policy, because as I don't push this image to any registry, it would need to pull that image again. So I need to change that from, I think it's if not exists, or something like that. If not present, so. So what I'm doing here is actually I'm going to the API, and I say I want to edit that configuration, and it opens up my editor, and whenever I save it, it applies that configuration to the API. So this is like a way to actually manually change things in your cluster. I could add environment variables. I could add change the image and some other configurations as well. So hopefully this works now. So let's see. Let's just run that deploy script. How about that? Doing bish deploy sh now. So building the Docker image. Okay. Connection refused. Yeah, obviously. So I don't have the server running anymore, so I need now go to 17 PhraseApp IO Let's run it again. Will be a bit faster because it doesn't change anything. So the update should be deployment finished. So bad gateway, not so good. Let me see. Yeah. The problem now is that the server still is forwarding port 80 to port 80 in the container, but that's it's listening on 3000. So I need to change that quickly. As I'm running this thing as root, I can just bind to port 80. Let's hope this works. Yes. So now I deployed that to the production thing, and I have my hitting colon 2 times and the deployment. As the image doesn't change, Kubernetes would just refuse to change. But yeah. So now let's like make this a little bit more API like, and for that I want to return a JSON response. And for that I thought of having a post which has a username maybe and a message. And instead of just writing a string, I would render that post as JSON. Username is, and message is this one here. So, and to encode that as JSON, I just say JSON new encoder, and I use W. Maybe now it's time to explain a little bit what that index is. That's just a function which fulfills the interface for the HTTP server. And so this is like there is no routing yet, and this function is basically giving me access to the response writer, so I can write back to the client. I can also set headers and also access to the request, so I get the method, the URL, the user agent, etc. Currently, as I said, I create this new post struct. And then I'm creating a new JSON writer, which is from the standard lib, and tell please write that JSON to the response. And then I just say encode P. Okay, hopefully this works. And what I'm also missing is to set the correct header. So that's set content type application JSON. So let's deploy that. So yeah, I will be cheating a bit now because having 3 makes the deployment actually way slower. What in? It's just a glitter of Tmux. Yeah, so little bit Go tooling. If I have source code errors here, for example, I would instantly be triggered that there is something wrong. For example, I would see that instantly. I really like that as well. So yeah, you see that I'm just writing down the JSON, and by default it just uses the names of the attributes. But as JSON is supposed to be, I like it underscored. There is a function in my in Vim Go which says please add tags to this these attributes, and I just say please add JSON tags. And that's more a little bit like Java annotations, I would say, where you say this name is actually not username major U, but like underscored. So let's quickly deploy that. And maybe we probably need to speed up a little bit if we want to put the database in as well. So yeah, but this is working, my JSON API, and all these deployments are wouldn't take much longer if I did that with my production code based to a production server, basically. So this is like the feedback cycle I would now get. Yeah, now we have like something which gives me some dummy, but I maybe also want to create posts, and for that I want a database. And now I need to speed up things a little bit. So first of all, I need a Postgres. Not so good as well. So kubectl run. Image is Postgres and Postgres. Okay, now we need to expose it. Deployments. Postgres. Okay, now I should have access to a Postgres, hopefully. Yeah, it's already running, cool. And so first of all, I need to create a create post action. That's also a handler, so I'm copying over the bits here. And as I said, I also have access to the request. So I know that my client should send the payload in a JSON form in the request, and I have access to request body. Cool. So I create a post, and then I can also use that JSON library to decode. So I say new decoder. Autocomplete is my friend. And then decode whatever I get through JSON here. Okay. But now I need a database, so I need to say SQL open, Postgres, and so code.talks. Let's see. Now I have a database connection. Obviously, I have to deal with error handling, so that will be HTTP error. So there is no there are no exceptions, just panics in Go. So you have to deal with errors manually. So you get them as a response. So this can also lead to an error, for example. So I'm generating some duplicate code here. Maybe I have time to refactor it later. So now I have a database, and then I can say write execute. Insert into posts, and then I say username, message, then I provide the, let me see, username. We'll probably be thinking, where is he writing to? Did he create the database yet? Or something like that. We will figure that out later. And then also, this is kind of annoying here, but I will refactor that so it doesn't compile because I cannot use this type reader. Yeah, I want to read from the body. But this is like a nice example of that trial and error thing. The compiler and my IDE basically tells me all the typos I'm creating. exec, it's called, yeah. And yeah, I also get a response, for example. So I could now deploy that, but I would need to add that to some router. And for that, there is like a specific package I use, which is a pad new. That's just a router where I say mux get is this thing here, mux. And for post, I would call that create post compiled. Okay, but I would still not have a database, so maybe speed this up as well. So kubectl exec. I'm now going into the container. Okay. And I want to run Postgres. Nope. What's wrong here? Bash. That's Postgres is not the command line tool. Create database, code.talks, and then I connect to code.talks. So I now access the container, and I can talk to the database because it's not in my network. And then I just create a table here. Create table, posts, username, and message. I will be probably skipping the 5-minute thing, so so it plays out a little bit better, I think. So the username should have. So you can ask me the questions after the talk. So create table, posts. varchar and message varchar. Okay, I should have the posts table. Let's see. Wonder what happens. I'm still in the Postgres container. Deploy it. Okay, I was still using the get, so now I'm posting something. Bad gateway. That's not so good. That's interesting. Any hints? Maybe it's time to look into the logs of the containers. That's like one of these exceptions which doesn't happen in Go normally. Probably running out of. I'm probably running out of connections. Yeah. This could be it. So we need to disable that first, maybe. Some logging. Let's deploy it quickly. Nope. Remove the deployment bits. What's the exception? So I will be trying to debug it locally, as I still have, I could still have access to that Postgres service. First of all, I delete it, because when I can also expose it as a node port. Node port service. So now I have access to Postgres here. So this would be hard coded. Okay, and I'm going back to go reload here, and obviously also localhost. Connection refused. Yeah, it's still like trying. It wouldn't be able to bind. I think that one resulted in an error. So, but this should work. Empty response. Yeah, and here now we see the panic. Maybe we should write tests for that. Panic serving runtime. Nil pointer. Multiple response. Oh, that's not good. Okay, first of all, I need to return after all these statements here. So here and here. No, it's in the creating. No, and now I get the end of file error. An end of file error means that there is nothing provided in the body, and this is happening here basically. So let's provide something. Now it tells me about the driver not being loaded, so then I need to load the Postgres driver. Okay, it said it created something. Let's see. Probably something empty. Yes. I don't have a validation for the username and for the message, so I'll quickly add the validation if p username equals or p message equals, and then I do something similar here. This is actually error code 400 because the client messed up, and I would say not valid. Really good message, not. So this works, but now the username. Username is yes, and message passed. Yeah. Yeah. Okay, now the method should be in the database. And if I quickly change this here, yep, thanks. That's the most extreme form of mob programming probably I've ever seen. Messed up the error? No, it compiled. Yes, thanks. Maybe we should have a mob programming track next time. That would be fun. Deployed it. Let's see. That was not so clever. Why not deploy a few times? So let's see. So the last one should be created in the Kubernetes cluster. So now I can write to the database. Yeah. So obviously I would like refactor this out. So maybe create a internal function, something like this, where I would just say return this error. And then say here, and return, and wait for the compiler to return something here. Yeah, but this is like, even though this looked probably quite chaotic, but this is actually the trial and error approach, which I really enjoy in Go. So I basically type something, wait for something to happen, and if I have a feedback cycle like that, I would probably not break our production side or something like that. Then it makes really fun doing. So I hope like that showed a little bit how that workflow works. Sorry for the weird issues. I should have probably tried it out a little bit longer, but yeah, thank you.